Hey everyone, so in today's GFG POTD, we need to remove every kth node. So as the question given here, given a single linked list having n nodes, your task is to remove every kth node from the linked list. So as the example given here, in the given example, as we can see, the number of elements are actually 8 and linked list are like 1, 2, 3, 4, 5, 6, 7, 8, and here the value of k is 2. That means we have to remove all the kth node. That means if k is equal to 2, so here we have to remove, this is my k is equal to 1, k is equal to 2, so we have to remove it. And this is my 3, again k is equal to 2, we have to remove it. And again 5, then we have to remove all 6, then again we have to take 7, then we have to remove 8. So our final output will be like 1357, which is actually present inside the linked list. So after removing every second node of the linked list, the resultant linked list will be 1357. Okay. Similarly, if we are talking about in example 2, we have a list of 10 elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and here the value of k is equal to 3. Okay, so that means if it is k is equal to 1, 2, 3, that means here we have to remove this. Again, my count is equal to 0. Okay, 1, 2, then again 6 is removing, then again 7, 8, then again 9 is removing. So output will be like 1, 2, 4, 5, 7, 8, 10. Don't worry, I'm going to explain you about these examples in brief. So here, first of all, I'm going to read the task. The task is to complete the function delete k, which takes head of linked list and integer k as input parameters, and delete every kth node from the linked list and return its head. So expected time complexity order of n, expected auxiliary space order of 1 space. That means I have to do with the same space. Okay, linked list and data structure. So basically in this problem, here I have taken the example 1, and for solving this problem, as we can see here, that is this basically list contains 8 elements. Here n is equal to 8, and here kth value is 2. That means we have to remove every second element of the list. Okay, so for solving this problem, what we can do, we know very well that this is my first node, which is actually my head node, and this is my head node, and I can see here, for solving this problem, I have to take also one variable count, which basically help us to solve the problem. Okay, so here I have to declare my count variable, which basically counts the number of kth when the k is equal to the node element, or sorry, when the kth is equal to the elements, then we can simply remove from the linked list and we have to move forward. So while solving this problem, first of all I have to define my base case. Base case means that like if we have one element only, like if we have only one element, then what we can write here, then we know very well if there will be one element, so the kth values, or maybe like if there are multiple elements also but the k value is 1, that means we have to remove all those elements after one by one position. Okay, that means we got empty list if the kth value is 1. Okay, so because if kth value is equal to 1, so we don't get any result. Okay, so here we can say that in the base case, that if my k is equal to 1, I can simply say that about that my whatever is my head, that head will become null, and I can simply turn my head. Okay, if we have, no, this is my base case, else we can say that if we have elements, if we have multiple elements but the kth position is not actually 1, it is more than 1, then what we can say here, for solving this problem, we have to declare a variable int count as 0, which basically help us, I can write it here, which basically help us to, which basically help us while traversing and removing. Okay, So here for solving this problem, we can solve this problem by using 2 pointers. So first I'm going to define my 2 pointers. Let's define no disturb previous. Okay, this is my previous element, which we can say that basically like here we can define as, okay, here I've defined my previous element as null, and I'm going to define my second node, which is my current node, and I can define here as let's suppose it is stay at my head position. Okay, now after declaring these 2 pointers, I need to traverse through my complete list. So for traversal I need to use this. I need to traverse until my current node will not become null. Okay, till I need to traverse my complete list, and inside list I can say that I have to move my count by 1. That means by traversing along with that I have to also increment my count, and I need to also check the condition. That means if my current if my count is equal to k, like if I got the value, like for example here if my k is equal to 2 here, so this is my k is equal to 1 and this is my k is equal to 2. If my k is equal to 2 is equal to like my count variable or my k, okay, because I'm actually traversing here. So if my count is equal to k, as the k value is given here, okay, so that means we have to remove it. So for removing, what I can do here, I need to make this element, that means this is my previous element, so I need to make next element. Okay, I need to make previous next. So here we can write it here. If my count is equal to k, then I can simply make previous next. I have to stop in previous next into current next. Okay, so that means we have to store we have to skip this value, and we have to store in previous next value the current next value. Okay, after doing this thing we can make our count as 0. That means we have to start it from starting. That means if my k is actually reached here, k is equal to 2, then we have to make k is equal to 0, then a fresh start from here. Okay, so again from here my k values, my count is equal to 0. Actually my count is equal to 0. So here again if my count is equal to 0, again the same process is going to take place, and if it is not my kth position, then I need to come out here from this loop, and I can say that here I have to store my previous equal to current otherwise, or I can say current is equal to current next, and simply I need to come out from this loop, and I can simply return my here turn head. Alright, now let's check the problem. So it's correct, let's submit it. So it's correct. So that's all for the today. Thanks for watching.